we get into more difficult equations to graph and are looking for a very precise intersecting point, I'm going to introduce you to a graphing calculator that is accessible on your computer. I highly recommend that you go and bookmark this. I will put the link on Edmodo, and it is called Desmos, and I will show you how that works. Now, this is right from your book, page 404, and we're going to see a couple different equations here, and we're going to use Desmos to help us graph those linear equations. As you can see in this first set, the equations are already written in slope-intercept form, and they have pretty simple intersecting points or graphing points. We have a y-intercept of 6 and a y-intercept of a -1, and we have a slope of 1 and a slope of -1. So this one is pretty simple to go ahead and graph ourselves. We get some here that we don't have as precise. We have some decimals, and those are hard for us to graph on our graph paper. And in this one here, we have them in standard form. So we would have to first change them into slope-intercept form, and then we have some, sometimes we have to do a little bit more simplifying, as in this last equation here, because we would have to, for slope-intercept, solve for a single y. So I'm going to show you this a little bit nicer way to do this than all of the graph paper. I know you're going to miss the blue graph paper, but I will show you how to use this. Now, the problem with using this, though, is you still have to understand the concepts behind the solution for these linear systems. So, we are now on Desmos, and this is what the program looks like. And what you simply do is, I'm going to type in, I know you can't see it because it's on the other screen, but I'm going to type in my first equation. And I'm going to type in, whoops, I was up in my, need to be down here, okay? I'm going to type in y equals, and I'm just using my, I got an, I don't know why I'm getting that right now, maybe because I haven't finished it. So y equals x plus 6. And you can see it's working here, and it's gone ahead and it has graphed my equation for me. Now, as I said, we can see this one pretty easily. My y-intercept is at 6, and my slope is 1. So we can see that this is going up at a 1 over 1, 1 over 1, oops, sorry, I should do it this way, 1 over 1, 1 over 1. So the slope is correct here. And we could have went ahead and graphed that ourselves. Now I'm going to add another one, whoops, add another equation. So I go down to number 2. They've changed this slightly since the last time I used it. And I'm going to type in y equals, and I'm going to have negative x minus 1. And now that I have that equation, as quick as I could put in the -1, we have that equation graphed as well for us. So again, let's just see that we would understand that. We have our y-intercept at a -1, that's right there. And we have a slope of a negative, this is a negative slope, and it's 1 over 1. So we can see that if we rise 1, then we're going to go over -1. If we rise down a -1, then we're going to, if we rise down a -1, then we're going to run a +1. You might also notice when I come to points that if I just hold my cursor over there, it will tell me that precise point. And that's why this is good for the system, because sometimes we can't read that. This one here does not end up at an exact intersecting point on our coordinate grid. We have that it's at -3.5 and then 2.5. Now you can see for this graph, they have they've changed it so that we can see each one of those. If this is 2, I have 1, 2, 3, 4 lines between it. This must be 3 here, so these are half marks. 2, 2.5, 3, 3.5, 4. That's a little bit difficult for us to put on our graphing worksheets. So that's why this makes it a little bit nicer. Okay, to do a new one, now let me see if I can remember how to graph a new one. I'm going to, whoops, go ahead and get rid of these. and I'm going to put in my next ones. So number 2 on page 404 was the ones that were not in slope-intercept form. 3x plus y equals a negative 2. That one wouldn't have been too hard to do because we have a single y here. And then our second equation for our system was x minus y equals negative 8. And again, this one would be pretty simple. We would have a negative y, so we'd need to translate that into a positive y. And we have that one is graphed as well. So the green line is our first equation. The purple line is our next. And we get an intersecting point, and I can't see that very well, so I'm going to make that a little smaller. And I get an intersecting point at negative 2.5, 5.5. So again, and you can see that they've broken up their graphing paper. It looks like ours, 1, 2, 3, 4, 5, but we have this one floating in the middle, so it'd be hard for us to say exactly where that is. All right. So again, if I do the next one, I'll do all 5 of these. So I'm going to do a negative 0.25 minus, oops, let's get an x there, minus y, and that's going to equal 2.25. I'm going to get my other equation is going to be a negative 1.25 plus 1.25. Oh, I forgot my x in there again. It doesn't know what to do then. Wasn't graphing because I didn't put my x in there, equals a negative 1.25. It's graphed both of them, and I can see this is my intersecting point. Now this one, the intersecting point, is easy to identify, but we would have trouble finding those exact points, the points to graph and to follow along for our slope, or maybe our intersecting point. Our y intersecting point would be a little bit hard for us to get exactly right. And that would be the same in this next one. We have negative 0.8 x plus 0.6y, and that's going to equal a negative 12. They have it as 12.0, so I'll do it the same as in the book. And then we have 1.25x, whoops, or z, x minus 1.5, and they put it as 0, so I'll do it the same, equals 12.75, and that's my blue line. Now you're going to notice here that I can't, besides my Mimeo tools, I can't see the intersecting point. You can't see this part on the screen right now, but over on the side we have a zoom out and a zoom in over to the right here. So I'm going to zoom out, and as I zoom out, then it's going to make my graph smaller, and I can find that intersecting point. Okay, so, and then there's a home that goes back to the original zooming in and out. Move my tools here again, and that was my number 4. Let's go ahead and do the last one. This one is a concept I haven't introduced yet in this chapter, but you can see how this works. So I have a 3x plus 9y, and that's going to equal 8. And my other equation is 2x plus 6y equals 7. Now, this is a little bit different because as we graph them, you're going to notice these are parallel lines. If we simplified these and solved them for y, we would have seen that they had the same slope. And if they have the same slope, they're going to be parallel lines. That means that they cannot be a system, a linear system. They will have no solution. There will not be any coordinate point that would satisfy both of those solutions. So this is a no solution. So that was just a quick little introduction to Desmos. And as I said, I'll put that link and you can play around with that a little bit. But you still need to understand that the graphing, they're doing the graphing part for you, but that an intersecting point means that is the solution. That's one of the solutions for both of those graph lines that satisfies both of those graph lines. So that makes it a linear system. And I gotta find my tools.